Today we're going to be working on verifying trig identities. This is kind of a neat thing to do because we're actually going to be given the answer. Please no miracle answers, all of a sudden 1 equals 1. But the goal is to get the left side equal to the right side. And what can we do? Well, the first one's pretty easy. Sine squared plus cosine squared. We know what that is. That's just 1. So I can write the entire top as just 1. Now the bottom, I'll go ahead and leave it for now. But you should recognize what secant squared is. Secant is just 1 over the cosine. So I can write this as 1 over cosine squared of x times 1 over cosine squared of x equal to 1. And hopefully we recognize these should cancel. And what do we get? 1 equals 1. We're done. Very easy to do these. Now, a couple things you want to remember. Try to use sines and cosines when you can. In the case that we're going to do for number 2, you may need to transform the denominator so we get a monomial. Now that's fancy speak for a single fraction, a common denominator. For example, like number 2 here, I want to get this whole the left side equal to 2 cosecant squared of x. I'm just going to start with something, and that's the thing here. Try something. So anytime I see 2 fractions, I want to get them as 1 fraction. And I do that by multiplying my denominators together. I get 1 minus cosine x, 1 plus cosine x. To get my numerator, we cross multiply. We get 1 plus the cosine of x, plus cross multiply here, 1 minus the cosine of x. Cosines cancel. And the top I'm left with 2. And on the bottom, if I distribute, I get 1 minus the cosine squared of x. That's a difference of squares. Hopefully we should recognize that from Algebra 1. And this is still equal to 2 cosecant squared of x. Well, from our last rules, we know that 1 minus the cosine squared is just the sine squared of x. So that equals 2 cosecant squared of x. And now you're like, oh, look, I'm almost done. Oh my gosh, how do I get them equal? So we think, oh yeah, what is sine squared of x? Well, that's the flip of cosecant squared of x. So if I flip my sign up to the top, I get 2 cosecant squared of x equal to 2 cosecant squared of x. And they're the same. That's our whole goal, get them the same. That's kind of fun, huh? All right, let's take a look at number 3. Now, number 3, you might be thinking, for number 2, I had to use my difference of squares. Will that work here? Well, no, because first of all, they're not doing difference of squares. And 2, secant squared, sine squared, not probably the nicest one. So what I can use is some trig identities. Now, it's not the only way, but this is, of course, going to be the easiest way, I think. Now, the first one, the second one, sine squared minus 1, we should kind of almost recognize this one. We know that 1 minus the sine squared of x equals cosine squared of x. But I'm flipping it. Now it's kind of like saying this. If I have 3 minus 2 equals 1, if I switch the order, I get the negative of it. And that's going to happen here. So if 1 minus sine squared is cosine squared minus 1, you guessed it, negative cosine squared of x. Now, secant squared of x minus 1, now that one's a little bit tougher. I always start off with cosine squared plus sine squared equals 1, and to get secant, I have to divide by cosine. So that's going to equal secant squared of x. This becomes tangent squared of x, and that's just plus 1. So what is secant squared of x minus 1 equal to? Bring over the 1. Tangent squared of x. So I can write this whole part as tangent squared of x. And remember, that's still equal to this negative sine squared of x. Oops, ran out of room there. Simplify. Go up to my rule again. Sines, cosines. I don't want tangent, so I convert tangent as sine squared of x over cosine squared of x. And that's going to equal negative cosine squared of x. And see if that's equal to negative sine squared of x. Notice I'm always copying down every step. You need to make sure you do that. That's very important for this unit. Cancel, cancel. We get negative sine squared of x equal to negative sine square root of x. We're done. Now, if you don't copy down the right side every step, we do mark it wrong. You know, you will lose a lot of points for that because the goal isn't to simplify the left side, it's to make it look like the right side, okay? Very important. All right, number 4. All right, now for a problem like number 4, this one's not too bad, but again, use the rule. I don't want to use cosecant. That's sine. This is just 1 over the sine of x minus the sine of x equals the cosine of x cotangent of x. Now it's a little bit different. I didn't convert the right side. Okay, I did not convert that to cosine over sine because I want to get the left side equal to the right side, which means I need to leave that alone. All right. Now what to do? I have 2 fractions, but you may be thinking, hey, there's no 2 fractions. Well, that's 1 over sine. This is sine over 1. Common denominator, just multiply. We get sine of x, and on top I get 1 minus the sine squared of x. Again, remember, copy down both sides. And again, what is 1 minus sine squared? It's cosine squared. Yeah, it's cosine squared. See, we already have it here. Very good. So we get cosine squared of x over the sine of x equals cosine x cotangent of x. And now I know what y'all thinking. How can I get cosine squared over sine equal to cosine cotangent? Easy. I have 2 cosines. Just if I'm side by side. Cosine x, don't forget it's not cos, it's cosine x over the sine of x equals cosine x cotangent of x. Well, if I put these 2 together, that's cotangent. So I got this cosine of x, this cotangent of x, and they are indeed equal. Ta-da! Very easy. Now, if you need to, go back, retry these, okay? These are very easy to do, but they can get pretty tricky. All right. Let's take a look at numbers 5 and 6 on the back. Okay? If you turn this over, let's take a look at number 5. Now again, I know what y'all thinking. Hey, look, Mr. Wernow or Miss Noonan, or hey, teacher, there's cosecant cotangent. I'm going to rewrite them. Yay for you. This is 1 over the sine of x plus cosine x over the sine of x equals the sine of x over 1 minus the cosine of x. Very good. Now, so what do we have on top? Ooh, look, we already have a common denominator over here. Sine of x. And on top here, what am I going to get? 1 plus the cosine of x equals the sine of x over 1 minus the cosine of x. Now we're going to do a trick here. We don't use terribly much often because I have a 1 plus up here. I want a 1 minus down here. I want my signs to be flipped. So what we're going to do is we're going to multiply by the conjugate because the conjugate will make this 1 plus into a 1 minus. And let's see what that will do. Multiply top and bottom by 1 minus the cosine of x. 1 minus the cosine of x. On top, that's a difference of squares. We get 1 minus the cosine squared of x. On bottom, we get the sine of x times 1 minus the cosine of x, still equal to all of this. Now this is a skill you're going to be seeing quite a bit, okay, in your homeworks and your assignments, your tests and quizzes, so make sure you know that conjugate rule. Now on top, oh yeah, I can actually factor this because, see, I want this 1 minus cosine squared, one of these to cancel, so watch what I can do here. I can cancel it. Or don't. Well, wait, actually, be careful. I don't want to cancel because I want that 1 minus cosine x on bottom. So I'm not going to factor it. I'm going to rewrite it. Because I don't want sine x on bottom, I want it on top. And what is 1 minus cosine squared equal to? But sine squared of x. Sorry, I love to factor. Any chance I get to factor, I factor. I'm at a restaurant and there's a sign, there's a math problem on the table. I'll factor it if I can. All right, so what we notice is this will cancel. So what am I left with? Sine x over 1 minus cosine x equals sine x over 1 minus cosine of x. And we're done. All right, the last one we're going to go ahead and do together, well, maybe we'll do one more together, is number 6. Now for number 6, we want to get this tangent squared of x over 1 plus secant squared of x equal to the following. Now right away, tangent squared and secant. That's one of my Pythagoreans. Now if you have trouble with it, write it this way. Cosine squared plus sine squared equals 1. I want tangent. That is sine over cosine. Remember, I don't memorize these. You don't have to. This is 1 plus tangent squared of x, thank you, equals the secant squared of x. So I could write tangent squared of x as secant squared of x minus 1. And that's what I'm going to do. Secant squared of x minus 1. Well, the whole rule here is just try something. Okay, these are not the only ways to do this. Some people do these much quicker than others. And the reason why I would do this is because now I can factor this top. If I factor the top, I get the secant of x plus 1, the secant of x, minus 1, all over 1 plus the secant of x. And that's going to equal 1 minus the cosine of x over the cosine of x. And notice these cancel right here. And I'm left with the secant of x minus 1 equals 1 minus the cosine of x over cosine of x. And I know what you're thinking. They're not the same. But again, remember, I don't want secant. I can write that as 1 over the cosine of x minus 1 equals 1 minus cosine of x over cosine of x. And I use my common denominators. Now this is a tricky one. I use my common denominators. The bottom, cosine of x, cross multiply, I get 1 minus cosine of x, see, there it is, equals 1 minus cosine of x over cosine of x. And we're done. Now, I would recommend you try all 6 of these again on your own paper, and what I would like you guys to do is try numbers 7 and 8 on your own. Now, the hint I'm going to give you is for tangent, you may want to write this as tangent of x times tangent squared of x, because this is your Pythagorean. Alright, and we will see you in class on Monday. Have a good Thanksgiving break. Bye.